So now for this one, it's more of the same. I noticed that equation 1 and equation 2 and equation 3, they all are solved for x. That's a good thing. So what I can do is I'm going to take equation 1, and I'm going to say x plus 2y plus 3z equals 9. I'm going to take the whole thing. I'm going to take the whole thing and multiply it by -1. Now, the reason I'm doing that is I'm going to make the coefficient of this negative, and the coefficient of this will leave as positive, and the x's will cancel. My 1 does not look the greatest. So now I'm just going to push this through the parentheses. All that really does, when I push that through the parentheses, whenever you multiply by a negative, it just changes the sign. So this becomes negative x minus 2y minus 3z equals -9. Okay? Then I'm going to take equation 2, and I'm going to do the same thing with that. So for equation 2, I'm just going to write that down. And equation 2 is x plus 3y plus 2z equals 5. I'm just going to add those up. By the way, this is still equation 1. I'm just going to add those up. These will cancel. I get 1y, and then this becomes negative z is equal to -4. So I'm just adding them up vertically. All right. Now over here, I'm going to do equation 1 again, but I'm going to do this one in red, and I'm going to say negative x minus 2y minus 3z is equal to -9. Then I'm going to write equation 3, and equation 3 is positive x plus 4y minus z is equal to -5. So when I do that and I add those up vertically, these x's cancel. I get a positive 2y here. I get a -4z here. And then over here, I get -14. Now, I want to cancel one more variable. What do you guys want to cancel, the z or the y's? Your textbook will do something like this. It'll say this is equation 4. It'll label this as equation 5. That's fine. But what do I do to cancel? What do you want to cancel, the y or the z? Doesn't matter to me. The z. So if I'm going to cancel the z, I need to multiply equation 4 by something such that it cancels with this z term. So that's a -4z. So what does this need to be? Positive 4z. So how do I make this a positive 4z? Well, I simply multiply by -4. -4 by this is -4y. -4 times -z is a positive 4z, right? And then -4 times -4 is a positive 16. Now I'm going to add these up. I get -2y. These cancel. 16 minus 14 is equal to positive 2. Divide by -2. Divide by -2. I get y is equal to -1. Okay, that's pretty good. Your textbook would probably label this as equation 6. So now that I know what y is, I just need another equation, and I can solve for z. So I'm going to use this equation here, and I'm going to say y minus z equals -4, but I'm going to plug in -1 for y equals -4. I'm going to add 1 to both sides, and I get -z is equal to -3. Divide by a -1, divide by a -1, and I get z is equal to positive 3. Now I just need to solve for x, right? Now to solve for x, I can use any x term. So I'm going to just use the first equation. I'm going to say x plus 2. I'm just going to use this equation. Plus 2 times the quantity for y plus 3 times the quantity for z is equal to 9. So we know that y is equal to what? -1. We know that z is equal to what? 3. So then this becomes x minus 2 plus 9 equals 9. Combine like terms. 9 minus 2 is 7, so we get x plus 7 equals 9. Subtract 7 from both sides, and I get x is equal to 2. So what does all that mean? Well, my solution, where all three of these planes intersect, is going to be x, comma, y, comma, z. Or 2, comma, -1, comma, 3. How could I verify this? Yeah, well, it's not Desmos, it's actually Algebra, but there's an online calculator. So if I go into Schoology and I go back to class, this classroom links, I click on that. I click on calculators and calculator tutorials, 3D graphing calculator. I'm going to open this up in a separate window. I'm going to also type in, oops, I got to move there we go. Move my face over here a little bit. And now I'm just going to type in the equation. So I've got x plus 2y plus 3z equals 9. That's the first equation. I've got x plus, double check this and make sure that Mr. Adams does not make a mistake, plus 2z equals 5. Then I've got x plus 4y minus z equals -5. Yeah. And then our solution, what was the solution again? It was 2, comma, -1, comma, 3. Is that right? Yeah, let me double check. 2, comma, -1, comma, 3. All right. So that's what we got. I'm going to change the color on these. So I could tell I like red, blue, and green. So we'll do blue. We'll do green. And maybe I like to have a really stark contrast on that. All right. So now, if I look at the graph, there it is. Plain and simple. That's where it crosses all three planes, right? So I did my math right. In other words, these three planes, which the equations are from, is where this crosses at. And plus, if you look in the back of the book, it tells you that too. All right. Let's just kind of draw that out. So this is this thing right here. Okay. Are there any questions on that? Oh, sure, for sure. All right. So I'll leave that up there for a second. So you guys can copy that. Okay. Any questions?